What is the radius, r, of the circle from the given figure? Choose the correct option. Construct center O, join the vertices of the smaller and larger triangles to the center O. Let beta be the angle subtends at the center by each apex of similar small triangles. This implies that the larger triangle apex angle or angle it subtends at the center O of the circle is equals to 120 degrees minus beta center O of the circle. Consider one of the similar small triangles and use cosine rule. We have that the square of 11 equals the product of 2, the square of r, and the difference between 1 and cosine beta. Simplify this result and solve for the square of r. That is, square r equals to 121 divided by the product of the 2 and the difference between 1 and cosine beta. We call it equation 1. Also, consider one of the similar larger triangles and use cosine rule. We have that the square of 26 equals to the product of 2, the square of r, and the difference between 1 and cosine 120 degrees minus beta. Simplify the result and make square of r the subject of the formula. We call the equation obtained by the square of r equation 2. Equate equation 1 and equation 2. Call it equation 3. Simplify equation 3 by using trigonometry identity to resolve cosine 120 degrees minus beta. Before substituting the new value of cosine 120 degrees minus beta, cross-multiply equation 3. Multiply the equation obtained by 2 to clear fraction. Our new result is shown on the screen. Combine like terms. After combining like terms, we simplify the result to have that 1473 multiplied by cosine beta equals to sum of 1110 and the product of 121, the square root of 3 and sine angle of beta. Using trigonometry identity, we convert cosine beta to sine beta and substitute in the last equation obtained for cosine beta as shown on the screen. Square the equation, expand the brackets and multiply out the terms with their outside common factors, respectively. Combine like terms, rearrange all terms in one side of the equations. Simplify the equation and solve for sine beta using quadratic equation formula. Substitute coefficient of the terms formed by the variable sine beta in the quadratic equation. We assumed you already known the general formula used to solve quadratic equation. For that reason, simplify the equation in sine beta as shown on the screen. Take positive value of your result as or because sine beta is positive in the first and second quadrants and we are solving for angle less than 180 degrees, sum of angles in a triangle. This implies that, simplify your result, sine beta equals the product 231 and the square root of 3 divided by 722. Use trigonometry identity to find the value of cosine beta since we have already obtained a value for sine beta. This value of cosine beta is shown on the screen. Simplify the value of cosine beta and we have 601 divided by 722. In equation 1, substitute the value of cosine beta obtained. Find the square root of the equation. The radius of the circle equals the square root of the product of 121 and 722 divided by 242. Simplify and we have that r equals to the square root of 361 which is equals to 19 units. Therefore, the radius, r of the circle is equals to 19 units. Option C is the correct answer.